أبناءنا طلبة الشهادات العامة، تابعوا معنا أقوى وأمتع البرامج التعليمية بأحدث التقنيات الحديثة والإخراج المتميز على باقة قنوات المحروسة للشهادة الابتدائية والإعدادية والثانوية العامة ومدارس اللغات والإعدادية الأزهرية والثانوية الأزهرية. تابعونا نضمن لكم النجاح والتفوق بإذن الله.
Good morning, my dear students. Welcome to our program for chemistry today. It's very important to know this information about chemistry today. It's very nice and concentrate with us.
Chemistry is a life. Without chemistry, no life. You know that well. Let's see step by step. Let's go now. Water. What about this lesson? It's wonderful.
The symbol is H2O. What are the properties of the water?
To know that, you must look at the water. The life, it has a lot amount of the water. We must study each part and the effect of the water for our life. Let's see as a beginning.
So here we have the sources of water. We have all life on earth depends upon it, upon what? Upon on water. We have here the water, it's found as 71% of the earth planet. So here we have the water of the sea. We have rivers water, fresh water to what? To drink. And we have some different types of this one.
It's good to know these different types, but as a beginning, you must know the main structure of the water. It's about 70% of our planet is the water. That consists of two main parts. As a beginning, it exists
as gas. It's found in the clouds.
It's good to say that, but you must know it has two atoms of the hydrogen, also one atom of oxygen. Do you think what this means?
This means this is two different elements that found in what? That found in this water molecule. So here we have bonds between them.
Good to say that. The water here is very important for the life. You must know we need to drink at least
about 2 liters per day.
It means you have 8 cups of the water. So the water can be found for different shapes, different structures, but all life depend on the main drop. It means
what? It means we have many molecules and 55% of the blood in water is found in our body. Flowing what? Flowing through our rivers of blood vessels. It is blood capillaries, blood vessels, veins, and arteries.
It's good to say that. The Earth is the only our planets that have water, can be found only on the Earth. Yes, this it means it covered as liquid. Now, the life of the Earth depends on the water. So, you can't say it's life-giving. The chemistry has natural in the earth. Now, do you know what else?
We have life maybe have first developed from the warm water, and we have the clouds that found in our sky. That makes what? That's condensed water vapor. That comes out from what? Comes out from our water wallet that found in the seas and river by the effect of sunlight, forming the condensation of water in form of clouds.
So, the molecule of the water, as you see, consists of the two main one. The ionic chemistry of the water makes a special of the universe. The first 2 atoms of the hydrogen that combined with 1 atom of oxygen. Now, what is the type of the bond for the water for this? And let's explore the magic of the water.
So here, the bond between the atoms here inside the molecule of water, we have 2 single covalent bond between these atoms of hydrogen and oxygen. But we have another type of bond that's found here in our molecule of water. What is this?
That is the existence of our life. All life depending on these bonds of the water. It means two single covalent. This not only, we have another one. Let's see this.
We have the ionization of water. So here we have this is pure water is very poor conductor of electricity, but some conductivity is detected. Again, it's very important to know this. So the ionization, it comes out from the ions. So here the pure water is very poor conductor.
Good. Ionization of the water. So some disionization must take place as shown in the following equation. Take care. You have an equation to explain what is the effect. The equation beginning with H2O. Oh, H2O may be more than molecules. It means you have greater than the bond here. Now, look at this. This reaction is reversible.
Reversible reaction between the two molecules of water here. Why? Because here the water, it contains 2 atoms of hydrogen and 1 atom of oxygen. The reversible reaction give the product of what? Of H3O positive ion. It's what? It's hydronium ion. And we have another one that called OH negative. That's what? Hydroxide ion.
It's good to say that you have two different types, hydronium or hydroxenium, H3O. It's good. Also the negative here, it means OH. This not all. You must also take it as H2O in reversible reaction. Do you think what happened after that?
Here we have the ions that formed by what? By the ionization of water into hydrogen positive ion and hydroxyl ion, this is negative, that form what? That's found in the solution, and we have here, this is the reversible reaction to form the molecule of water again.
You have two important charges. For the first one, the first ion, hydrogen, this is a positive, this one molecule only of the water. The other one, hydroxide ion, for the negative one. Also, we can say as Kw. Do you think what this means?
It means what? It means the constant equilibrium constant of water here. It's equal what? Equal hydrogen positive ion, that power of 1. Why? Because we have here 1 mole or 1 ion of this hydrogen times what? OH negative divide H2O as what? As the product. Why we write this equation like this?
We write it like this to catch the concentration of the product per concentration of the reactants. It's good to see that, but we work through ionization. So you can say Kw for this case equal 10 power negative 14. Oh, do you think what this number indicate what?
Indicate the equilibrium constant of water of what? Of this hydrogen positive ion and hydroxide ion is negative. So here this is the total of this one.
Good, as 10 power negative 7 also by 10 power negative 7, so directly we arrive to 10 power negative 14. Look at this, H positive, also OH negative. The result for this will be some 10 power negative 14. It's great and wonderful. Let's catch the other part.
The other part about what? About the Kw equal H positive times OH negative equal what? Equal 10 power of negative 14. So it is what? It is the water is neutral on litmus paper or litmus solution. It doesn't affect the litmus paper or doesn't affect the litmus solution by any changing of colors.
This neutral back to the presence of H positive, OH negative. Also, you can say Kw equal 10 power negative 7 by 10 power negative 7. So, directly we can say 10 power negative 14. Don't forget, this number indicate concentration of the hydrogen ion multiply concentration of hydroxide ion. Good and wonderful. What about to catch this? Look.
Here we have the Kw, ionic product of water. This, what's meant by this? We have the ionic product of water is the resultant of multiplying what? Multiplying
the concentration of the hydrogen ion, H positive, times the concentration of hydroxide ion, OH negative. I like it. This not the all. Catch the other.
It is the constant value that equal what? That equal 10 negative or power of negative 14 mole per liter. So this is what? This is the value of Kw.
Good to say that, but I have a question. What is meant by mole per liter?
It means the concentration of the water here. It means 1 mole in 1 liter.
Good to say that. Concentration of multiplication H positive, OH negative. Great and easy. Now, if the concentration of hydrogen ion increase, do you think what happened?
Yes, the concentration of hydroxyl ion decreases with the same amount. Do you think why?
Yes, we know, because both of them has mean number 10 power negative 7 by 10 power negative 7, the result 10 power negative
14.
It's good and great. Catch it now. My dear, this is the molecule of the water. Now, look at this.
Here we have the molecule of water that contains 2 atoms of hydrogen and we have 1 atom of oxygen. Add the salt crystals here to make what? To make dissociation of the water, dissociation of salt in water. Polar charge of water molecule, less the charges here, let them to make what? To make the dissociation.
Now, sodium ion is positive, chlorine ion is negative. It starts to be ionized. It starts to be decomposed in the water. Which ionized, we find that, look, positive from the water with negative from hydroxide or NaCl. And the opposite, positive from NaCl with negative of the water. It means
what? It means this is ionization and ions that attracted to what? Attracted to the water molecules or between water molecules and what? And the salt molecules.
It's good to say that. My dear, we have an example. This example say sufficient acidic solute is added to the quantity of the water produce what? H3O positive. You remember what this mean?
It's the concentration or equilibrium constant of what? Of the H3O positive hydronium ion positive equal 7.50 times 10 power of negative 5. So we have the complete the example.
The example also tell me what is the OH negative in the solution. OH, it means hydroxide ion. My dear, you catch this as steps. The answer beginning with concentration of the hydrogen multiply concentration of OH negative equal what? We have a fixed number. It means
10 power of negative 14.
This is the mean law. Now, exchange OH negative equal 10 power negative 14 per H positive. Now, what you have?
Here we have 10 negative 14 times what? Times hydrogen positive, it's equal 7.5 times what? Times 10 power of negative 5. So this the example will be 10 power of negative 18 times or what? Or divide the 7.5 times 10 power of negative 5 equal 1.33 times 10 power of negative 10.
My dear, now what about pH value? Oh, pH, it means what? It means
the concentration of hydrogen ion in each compound, acid or base or salt.
It's good to say that. Hydrogen exponent. Now, my dear, look, it's the negative logarithmic of the hydrogen ion concentration. pH equal negative log. It means logarithmics. Yes, concentration of hydroxinium, H3O positive. The symbol P means negative log. Good and great. Look at this.
Here we have the scientist or the person here that tried to make pH scale and know the pH scale of each one of these liquids and the solution. So he take some amount of what? Some amount of these colors or indicators here to make what? To make the differentiation between these liquids. If I have 4.5 for example, so it is acidic, and we have 9.5 here. It means what? It means this is the base 1.
So you can say the scale beginning from the 0 to 14. It means from the acid to base. Between them we have a neutral. Now we try to stir each solution to see what its effect. This is acidic or neutral or basic. I don't understand to catch it, but you must know the acidic all time beginning from
1 to less than 7.
It's good to say that 7 to 0. It means acidic. What about 7?
7, it means the neutral solution or neutral liquids.
It's good. The neutral, it means between acid and base. Now, what about the basic solution? Start from
more than 7 to what? To 14. This is what? This is the scale of the base.
It's good. Now, different solution with different colors. I want to catch which one of them acid, which one is a base. As you see, the colored tube by the orange or by purple color, as you see, it means this is acidic, but I'm not sure that the other one start to be blue or cyan. Now, I can't differentiate between them, but I ask, can we differentiate between them?
Yes.
How can you do that?
By using what? By using the excess of some kind of indicators to make what? To make a changing of the colors between acid and base. If I have the acid, it's what? It takes the color or different colors like what? Like blue.
Now, when we add the blue color, it changes from the acidic to basic. Like the scale tell me about 9.5. It means the concentration of basicity increase, so you have basic solution. Catch it, my lover. Basic all time beginning from 7 to
14.
What about 3?
3, it means acidic.
Good. What about if you add a more solution? What about the scale?
So the scale, it may be what? 2.5, for example. It's what? It is in the acidic area or region of acidic pH. Why? Because the color here doesn't change, or it change into red color or pink color. So we have two types of colors here. What are they?
The first one, as you see, this is as an orange. When it added to the solution, which is a basic, it decreased and will be acid. Also, if we make the opposite, the acid will be the base. Now, all solution in our life can be divided into 3 main solutions. As
what? As acidic, and we have the basic solution, and the other one is salt solution or neutral solution.
Catch this, my lover. This way, for expressing the degree of acidity or alkalinity for aqueous solution. Why we say aqueous?
Aqueous because we have the water is found in the solution. We make solution by using water molecules.
It's good. Now, referring to the ionic product of the water and using the negative logarithmatic of this equation. See the equation.
Equation here, P Kw. It means negative log of the concentration of the water, of the ionization of water here, equal pH plus POH. Equal what? Equal 14.
Good to say 14. This number, it means summation of hydrogen and OH. Look at this now. These ions of the positive and negative in our life. It means we have ionization. This form is a type of the water. It means
the water molecules here, and we have some kind of positive and negative cube of salt. So here the water, we use it in making solution. So here in this one or this type of solution, we have dissociation of water and the salt and water that found in the sweat. So here this is what? This is the solution sweat. It means the solution of salt dissolved in water by ionization of the salt solution.
Good. Now if you add HCl, hydrogen chloride, the hydrogen is a positive, chloride is a negative, and add another one of sodium hydroxide. This is a reaction between two main parts. The first is
HCl.
it means it's
An acid.
good. What about NaOH?
It means the hydroxide one.
It means what?
It means it is basic
Good.
solution.
The reaction here between basic and acid. Why we do that? To arrive
To make equilibrium between what? Between the acid and base.
I think this not only our body contains the acid and neutral solution can move through different cells in our bodies. It means we have a blood and this blood contain different type of the ions, positive and negative. So the heart start to work. What about this charge that move through it?
We have the charging here in the blood. We have many parts of ions like iron, for example, is found in the blood. And we have the water in form of plasma to make what? To make equilibrium between them. Equilibrium, it means the H positive ion. We have OH negative ion that makes what? That makes this equilibrium to form H2O.
Look at this, the acidity decrease until arrive to main point. This is 7. Now we have a water, O and OH, OH and H. This is neutral solution. This is the water. Less than this 7 will be directly
to the acid. So here, more than 7, it is base, but less than 7, it is acid. So here, more than 7, we have the hydroxide, and it's called what? It's called base.
So we can change acid to base and the opposite. Sometimes we have the acid sweat. Look, when everything changes, the ion change, it means it changing the shape of the water from acid to base, or from less acid to more acid, or from more acid to less acid. Now, the life is different depending on the human body. So the human body has a different shapes of the acids and bases.
We have acids, bases, or salt. We have table salt, for example, sodium chloride, that we add to what? That we add it to our food every day. And we have the lemon juice, vinegar. We have some kind of juices that contains acid. And we have the heart here. It needs these types of ions to move the blood inside what? Inside our blood vessels.
Now, this acid not stop to the human body, but we can use it for the washing, for computers, for different part in our life. The acidity and the basicity is important to us. What about to get the pH value equal 7 and
the pOH value equals 7.
Oh, both of them equal 7?
Yes.
Do you think why we say that?
Because we have the alkali and the neutral, and we have acid. Neutral, it's 7. So the pOH in the salt solution, it's equal 7. And we have the pOH, and here we have the battery acids here. Lemon juice, pH equal 2. And we have this lemon juice, it is very acid. It's what? It is an acid.
Look at this, fresh distillated water. Yes, we know it's neutral. Back to the normal water, it's neutral. What about seawater?
Seawater, it more than what? It is the equilibrium or neutral also, because it is what? It is salt solution.
In the case of an acidic solution, the pH value is less than 7 and pOH value greater than 7. pH less than 7, it means
this is acid.
Good. pHO, it means pOH greater than 7 means
it's what? It is the base.
Good. Now look at this. You have hot water and cold water. This experiment tell me what is the effect for the acidity and basicity. For the first one, we try to add equal amount of the water and some of the salts. Now look at this.
Here we have some amount of colored compound that dissolve or salt that's found here, and inside what? Inside the cold water and inside the hot water. And we will take it and leave it for a period of time. What will happen here?
For these cases, the agent exchange the color for each one. but the cold water, it's more dark than hot water. Why it's darker? I want to ask. This may back to
the effect of heat energy and equilibrium here.
it's good equilibrium all time to arrive to the neutral one, but the temperature here decreased for the hot water is higher in hot water, decreased for cold water. Do you think this stay as it is? What is the pH for the hot water? Do you know it?
Yes, we have the hot water, it's what it is 7, and we have the cold water is 7.
But I'm not sure which one the acid, which one is what is a base. Now, I want to find the scale to tell me the difference between them.
So,
we
use the apple vinegar or any type of vinegar to see the difference between the hot and cold water in this case. So I add some drops of the vinegar. Vinegar, I know it is an acid. So here we have the acid here to make what? To make this type of experiment.
Catch it, my lover. We have an example to tell me that. Look at this example. Calculate the pH for each of the following solution. Then identify the nature of the solution. How can you do that?
Here we have letter A, H3O. It's positive ion of hydronium ion equal 1 times 10 power of negative 3. Letter B, we have H3O. It's positive ion of hydronium equal 1 times 10 power of negative 9. Calculate the pH of each of the following solution.
Now, to answer this, we must make many steps. As a beginning, A, pH equal negative log H. What else you can say? Negative log H3O, hydronium or hydroxonium. Now, you find the answer as
negative log equal 1 times 10 power of negative 3. It's equal what? Equal negative 3 or equal 3. Why here we have pH equal 3?
pH 3, it means the concentration of the hydrogen here is increased. You have an acid. Now, what about this solution? Acidic solution. Good and great. Now, can you find the B?
Yes, it's very easy. We have pH equal negative log of what? Of OH or H3O also. We have 1 times 10 power of negative 9 equal negative 9. We have minus log here or negative log, so it's changed it into 9. So here, this one is what is the type of this solution is what?
Is a basic alkaline solution. Basic or alkaline solution, back to the concentration here will be 9. So 9, 7 or 3. 3, it means
less than 7. It is acidic solution.
7, it means
it is neutral solution like water and salt.
9, it means
more than 7, so it is alkaline solution. It's a basic solution.
It's good. This is the scale to differentiate between their types.
Dear friends, I hope to enjoy your time with us. It's a very interesting part about our curriculum today. Till we meet again, thank you and goodbye everybody.
Good. And I want to say start well because we need to work all time. The work is very important. No chemistry without working. See you and goodbye.